In this video, we will solve this partial differential equation, which is partial square u over partial t square minus c square partial square u over partial x square is equal to 0. And the boundary conditions are u of x and 0 is equal to f of x, partial u over partial t at t is equal to 0 is equal to g of x, u of 0 and t is equal to 0, u of L and t is equal to 0. We will solve this equation by separation of variable. Let u, which is function of x and t, is equal to v of x omega of t, which is equal to v omega. Put this equation in equation 1, so this becomes partial square v omega over partial t square minus c square partial square v omega over partial x square is equal to 0. Since omega of t is the function of t, so partial derivative of omega of t with respect to t exists. And similarly, v of x is the function of x, so partial derivative of v with respect to x exists. So partial derivative change into ordinary derivative. So this becomes v d square omega over dt square minus c square omega d square v over d x square is equal to 0. This is equation number 2. Divide equation 2 by v omega. So this becomes 1 over omega d square omega over dt square minus c square over v d square v over dx square is equal to 0. This can also be written as 1 over c square omega d square omega over dt square is equal to 1 over v d square v over dx square. This is equation number 3. Left hand side and right hand side of equation 3 is equal to some constants, which is lambda, and lambda is separation constants. So equation 3 become 1 over v d square v over dx square is equal to 1 over c square omega d square omega over dt square is equal to lambda. This is equation number 4. Equation 4 implies 1 over v d square v over dx square is equal to lambda, and 1 over c square omega d square omega over dt square is equal to lambda. This is equation number 5, and this is equation number 6. Equation 5 can be written as d square v over dx square minus lambda v is equal to 0. This is equation number 7. And equation 6 can be written as d square omega over dt square minus c square lambda omega is equal to 0. This is equation number 8. Now we have considered u, which is function of x and t, is equal to v of x omega of t. So u of 0 and t is equal to 0 means put x is equal to 0 in this equation. So u of 0 and t is equal to v of 0 omega of t is equal to 0, which implies v of 0 is equal to 0 and omega of t is not equal to 0. Similarly, u of L and t is equal to v of L omega of t is equal to 0, which means v of L is equal to 0 and omega of t is not equal to 0. So v of 0 is equal to 0 and v of L is equal to 0 is the boundary condition for equation 7. Now we will consider following case. Case 1, when lambda is equal to 0. Case 2, when lambda is equal to alpha square. Case 3, when lambda is equal to minus alpha square. Case 1, when lambda is equal to 0. Equation 7 is d square v over dx square is equal to 0, and the solution of this equation is v of x is equal to c1 plus c2x. Now we will use boundary condition, which is v of 0 is equal to 0, v of L is equal to 0. V of 0 is equal to 0 implies c1 is equal to 0. So v of x become c2x. Now we will use second condition, which is v of L is equal to 0 implies c2L is equal to 0. Since L is not equal to 0, so C2 is equal to 0. So V of x is equal to 0. When lambda is equal to 0, then equation 8 become d square omega over dt square is equal to 0, and the solution of this equation is omega of t is equal to c3 plus c4t. Since u, which is function of x, and t is equal to u of x omega of t, when lambda is equal to 0, u of x is equal to 0 and omega of t is equal to c3 plus c4t, and u of x and t is equal to 0. Now we will consider second case, when lambda is equal to alpha square, that is lambda is greater than 0. So equation 7 become d square v over dx square minus lambda square v is equal to 0, and the solution of this equation is v of x is equal to c5 exponent alpha x plus c6 exponent minus alpha x. Now we will use condition, which is v of 0 is equal to 0 and v of L is equal to 0 to find the value of c5 and c6. V of 0 is equal to 0 implies c5 plus c6 is equal to 0, means c5 is equal to minus c6, and v of L is equal to 0 implies c5 exponent alpha L plus c6 exponent minus alpha L is equal to 0, and c5 is equal to minus c6. So this become minus c6 exponent alpha L plus c6 exponent minus alpha x is equal to 0, and exponent minus alpha x minus exponent alpha x multiplied by c6 is equal to 0. Since exponent minus alpha x minus exponent alpha x is not equal to 0, so c6 is equal to 0. If c6 is equal to 0, then c5 is also equal to 0. So v of x is equal to 0. If lambda is equal to alpha square, then equation 8 become d square omega over dt square minus alpha square c square omega is equal to 0, and the solution of this equation is omega of t is equal to d1 exponent alpha ct plus d2 exponent minus alpha ct. u, which is function of x and t, is equal to u of x omega of t. U of x is equal to 0 when lambda is equal to alpha square, and omega of t is equal to d1 exponent alpha ct plus d2 exponent minus alpha ct. So u of x and t is equal to 0. Now we'll consider third case, when lambda is equal to minus alpha square, that is lambda less than 0. So question 7 become d square v over dx square plus alpha square v is equal to 0, and the solution of this equation is v of x is equal to d3 sine alpha x plus d4 cos alpha x. Now we'll use boundary condition, which is v of 0 is equal to 0, v of L is equal to 0, to find the value of d3 and d4. V of 0 is equal to 0 implies d4 is equal to 0, and so v of x become d3 sine alpha x. Now we'll use second condition, which is v of L is equal to 0 implies d3 sine alpha L is equal to 0. Since d3 is not equal to 0, so sine alpha L is equal to 0, and alpha L is equal to sine inverse 0, which is equal to n pi, and n is equal to 1, 2, 3, so on. So alpha is equal to pi n over L. So v of x is equal to d3 sine n pi x over L. If lambda is equal to minus alpha square, then equation 8 is d square omega over dt square minus plus alpha square c square omega is equal to 0. And the solution of this equation is omega of t is equal to d5 sine alpha c t plus d6 cos alpha c t, and alpha is equal to n pi over L. So this is equal to d5 sine n pi c t over L plus d6 cos n pi c t over L. U, which is function of x and t, is equal to u of x omega of t. U of x is equal to d3 sine n pi x over L, and omega of t is equal to d5 sine n pi c t over L plus d6 cos n pi c t over L. This is equation number A. Let d3 d5 is equal to an, d3 d6 is equal to bn. So by superposition principle, u of x and t is equal to summation n is equal to 1 to infinity an sine n pi x over L sine n pi c t over L plus bn sine n pi x over L cos n pi c t over L. Now we'll use condition, which is u of x and 0 is equal to f of x. It means put t is equal to 0 in this equation. So this term is equal to 0 and this term is equal to 1. So this become u of x and 0 is equal to f of x is equal to summation n is equal to 1 to infinity bn sin n pi x over l. This is equation number B. Multiply equation B with sin m pi x over l and integrate with respect to x from 0 to l. So this become integral from 0 to l f of x sin m pi x over l dx is equal to summation n is equal to 1 to infinity bn integral 0 to l sin n pi x over l sin m pi x over l dx. If n is not equal to m, then this integral is equal to 0. If n is equal to m, then this integral become integral from 0 to l f of x sin n pi x over l dx is equal to bn integral from 0 to l sin square n pi x over l dx, and this integral give us l by 2. So bn become bn is equal to 2 by l integral from 0 to l f of x sin n pi x over l dx. Now we will find the value of an. Now we will use second condition, which is partial u over partial t at t is equal to 0 is equal to g of x. It means take partial derivative of this equation with respect to t. So partial u over partial t is equal to summation n is equal to 1 to infinity an sin n pi x over l cos n pi c t over l n pi c over l minus bn sin n pi x over l sin n pi c t over l n pi c over l. Now we have to put partial u over partial t at t is equal to 0 is equal to g of x. So this term is equal to 0 and this term is equal to 1. So this become summation n is equal to 1 to infinity an sin n pi x over l n pi c over l. This is equation number C. Now multiply equation C. Now multiply equation C with sin m pi x over l and integrate with respect to x from 0 to l. So this become integral from 0 to l g of x sin m pi x over l dx is equal to summation n is equal to 1 to infinity an integral from 0 to l sine n pi x over L sine m pi x over L n pi c over L dx. If n is not equal to m, then this integral is equal to 0. If n is equal to m, then this integral become integral from 0 to L g of x sine n pi x over L dx is equal to an n pi c over L integral from 0 to L sine square n pi x over L dx, and this integral is equal to L by 2. So this becomes an n pi c over L multiplied by L by 2. L and L cancel out, so this becomes an multiplied by n pi c over 2. So an is equal to 2 over n pi c integral from 0 to L g of x sine n pi x over L dx.